Today we're going to be discussing Trimble Business Center and specifically the GIS module that will allow us to integrate survey and GIS data seamlessly together. The things we will go through are an overview of the GIS module for TBC, connecting to the GIS data source, whether that's a file geodatabase, an SDE, or shapefiles, and then how to manage the coordinate systems in between TBC and your GIS data source. Then we'll go through the survey workflow of creating an FXL to extract the schema out of the GIS data source and how to get that over to Access. Then we'll go through a feature extraction from an SX10 data cloud. And then we'll go through the mapping workflow, which will be importing a TerraSync SSF file, processing that baseline to differential correct the data, and then writing all of the data to a GIS data source. And then how can you get started using the GIS module? The first thing to discuss is the different terminology between the two software. So GIS has its own terminology and so does TBC, so we need to kind of explain how those correlate to each other. So a geodatabase on the GIS side is similar to a feature code library through TBC. Then as you can see down there, data sets and categories line up. Features are still features, attributes and attributes, and then we have list versus domain. The data dictionary is similar to an FXL, so that'll be kind of the schema that you'll be putting on the handheld to actually collect the feature and attributes into. And then the schema and feature definition is the structure of your database. So if you've been working with CAD to GIS data transfers a lot, you'll kind of have somewhat similar of a workflow to what's on the screen here. And as you know, those steps for exporting may need to be repeated multiple times and adjusted till that all the data and all the attributes come across from one to the other and they're all aligning. So you can see that those couple simple steps can turn into a lot more steps very quickly. The GIS modules will be an actual add-in that goes into the TBC software and translates directly to the GIS data source, usually through like Esri. So there is some limitations on the functionality of translating data back and forth due to Esri's API. So with a file geodatabase, you don't have editor tracking, geometric networks, topologies, or relationship classes. If you do have an SDE or an enterprise setup, then you are at least allowed to do relationship classes, so you'll be able to do attachments or different tables through that data source. And then shapefiles don't have those limitations because they don't have that functionality built in with them to begin with. So now we'll start stepping through the process of what you'll actually do and how to use the GIS module. So the first thing we'll do is set up a GIS connection through the GIS connection manager. So that allows you to point to your data source, give that source connection a name. So if you have multiple databases that you're connecting to, you can give them each separate name. So you've got one for your parks data set, you've got one for your water, utilities, and so on and so forth. And then you'll just browse to where that data source is, and then it'll map it for you, and it'll be usable through the next steps down the line. One of the biggest things that you have to watch with using the data source connection is how to manage the coordinate systems. So you'll see that we have three options there. So the first one is to change the project in TBC to match the project of the coordinate system. So if you do that, then your GIS data coordinate system is going to translate across to TBC. So if your GIS database is in a state plane system, then it's going to make TBC into that same state plane system. The next one is to keep the project for TBC and the GIS coordinate systems the same, and then you can do a transformation between them. So if your GIS source is using a state plane and your TBC is using a UTM, you can set a transformation between those two coordinate systems so that all your data lines up. And the last one is to consider the TBC project and the GIS coordinate system the same. So this one you have to be very careful in using and making sure that everything is indeed matching up. If you select this one and your data is in two different coordinate systems, or you have a different measurement of units on those coordinate systems, then the data, when it is sent back and forth, is going to be misaligned. So be very careful when using that third option. So this is kind of a display of how the coordinate systems are writing to each other, and how they're moving between the GIS source, Trimble, and that middle GIS module is translating the data as it goes. And you can click the details option on that coordinate system transformer that we were looking at. And so in that instance, it'll give you the coordinates of both of your databases. So the column that says database is your TBC, and then the imported is your GIS data source. So you can make sure that those are matching up before you choose whichever transformation you want to set. So the next thing is to read the data from the GIS. So this will import any existing features. So you can see there at the top, you'll select your database connection. So we'll select our water utilities that we had set up, and then we're going to import whatever features are already existing into our TBC project. Once we get the project set up and connected, then we can go ahead and create the FXL that we can use in Access for data collection. So it goes along the similar steps. You'll select your data source connection, and then it'll import all of the feature classes that are within those data sets. And you can expand them and look at the different fields and toggle them on and off. So you can toggle off the features themselves. As you can see, we turned off the parcels in the tree, but we just have all the water data coming across. And then down at the bottom, you'll choose a name as well as a place to store it. And then you can export the GIS source into an FXL. So now we'll go ahead and we'll jump into a demo. Now that we've switched over to TBC, we're going to go to the GIS tab, and then we're going to click on GIS Connection Manager. From there, we're going to click Add, and we're going to type in a name for our connection. So I'm going to give it a name that has the data as well as the data source. And then in the drop-down, I'll select File Geodatabase Provider. So now it's going to pop up the Browse window so that I can go and select my database. So I'll go ahead and click on it and hit OK. And then it's going to pop up my coordinate system mapping. So if I click on the details, it's going to pop up the report. And it's going to show me the information about my TBC project and my GIS source. Ours should be the same as we started our TBC project with our GIS source coordinate system, so I'm going to consider both of mine to be the same. So then I'm going to go ahead and hit OK, and then I'll click Close. So that's added in the connection. If we need to do more of those, we can. We'll just go back into the coordinate or GIS Connection Manager, and we'll click Add again and keep adding other data sets that you may need. The next step in the coordinates or GIS module is to do the read features from GIS. So this is going to import any features that are existing in our database. So all I want to bring in is the parcels. So I'm going to toggle off the existing water data that's in my database. And then I'm going to go ahead and hit OK. And it's going to load, and then it's going to show those parcels in my window screen here. So you can see my parcels just imported. So that was what was existing in my database, has now brought over into TBC. So now if I want to go collect some data with Trimble Access, I need to get my FXL. So to do that, we'll click the Get GIS Schema. And we've got our database connection there at the top, and then it's going to bring in the different data sets from our database. So all I want to collect is water data within Access, but I'm also going to be extracting the trees from the SX10 data. So the parcels I don't want to collect any new data for, so I'm going to go ahead and check those off. And then in the description, I'm going to give it a name. And then for the FXL file name, I'm going to browse. So it's going to pick up our description as the name, and then I can choose where to save it. And then I can do the export to FXL, and it'll create that. And I had the optional box checked to go ahead and automatically open it in the feature definition manager. So it'll pop up here. So you can see if we expand our parks, we've got our trees in there, and then we've got our water distribution. So if we want to edit the codes, we can. So I'll click on the control valve. So now I can go ahead and change my code. So you can make some changes to your FXL. You just have to be careful not to edit the schema. So that would include changing feature names or adding features. If you add it, you need to add it to your GIS data source as well. So you just have to make sure that those schemas are always matching, or it's not going to write everything over to your GIS data source. This next section will be geared towards the surveying workflow. So it'll be using Trimble Access. For those of you not familiar with Access, it's a survey level data collection software. So to be able to process the Access data, we'll have to add in the FXL to our TBC project, and then we'll go ahead and process the feature codes, and then we'll be able to edit any features or attributes that were not collected correctly in the field before we send them over to the GIS data source. After that, we're going to go ahead and we're going to extract data from the SX10. So the SX10 is a scanning total station, so it creates the point cloud. From that point cloud, they already have some preset extraction points. So that'll grab our buildings, our ground, high vegetation, which will be our trees, poles and signs, and power lines. So to do that, we'll use the point cloud tab, and then it's going to go ahead and extract it so we can map where we want these features to go into. So we're going to take it to that trees from our FXL, and then we'll map the attributes as well so that we can record some of that attributes that it's going to automatically extract for us. So it'll take it from looking like the first picture, and it'll extract, and we'll see our trees as shown in the second picture. So we'll go ahead and jump in and do the demo now. All right, if we pick up where we left off, the first thing we'll want to do is add in that FXL. So we're going to go into our settings, and then we're going to go into our feature code processing, and we'll see the feature definition file. So that'll be where we want to add it. So we'll click the browse button, and then we'll go to our folder. And so I've edited some of the feature codes already in another FXL, so that'll be the one I add instead of the one I just created earlier. So I'll hit OK, it's going to add it in there, and then I'm going to hit OK again. With our FXL added, we're now going to process the feature code. So we'll go ahead and click the Process Feature Code button. We'll select the JXL, which is the access data file, and then we'll hit Process Source. And you can view a report if you wish. We'll go ahead and hit Yes on it. And it'll pop up our report. So if we scroll down here, we can see everything that it imported. And then we'll go back to the map view. So now if we want to go ahead and extract those point cloud features, we're going to go to the point clouds tab. And then we're going to go ahead, I'm going to turn off the parcel so it's a little easier to see. So now we can extract point features. It's going to give us a warning about the high vegetation. We'll just go ahead and hit yes. So we'll go ahead and we can have it extract the different classes in there. We'll select the map, sorry. Select the point cloud and then go ahead and hit extract. Okay, so that took a few minutes to run, and now we can see that it's changed the layout there, and we can see that it's picked up the different trees and the buildings and the streets and all those different regions within the point cloud. So now we can go ahead and close this, and then it'll actually have the extraction for the point features. So the type we want to select is, of course, the trees. We're going to have it do it automatically, so let's extract the tree attributes, and we'll let this run for another minute. Okay, so now our tree extraction has been completed, and we can see that it's picked them all up here. So now we can start filling out the attributes. So for my starting point, you need to make sure you give it a big enough number that it's not going to create duplicate numbers. So I'm going to go with 2000. So it's got the layer there as trees, and then we're going to want to put in our feature code. And now we can go ahead and map the attributes. So the tree spread, I can go with spread, and then diameter, and height. So we can go ahead and click add, and it's going to extract those. It's going to ask if we're sure, and I can go ahead and hit yes. And you'll see that they all just populate with the number incrementing that I created within the starting point. If we want to change the tree symbology to make it look like an actual tree, we can at this point. So if we expand our feature libraries over in our Projects Explorer and go into the trees, we can right click and do a new symbol. So we can give that a name, and then we can click on our symbol type, and we'll see that we've got some added in there. If you want to import your own symbol, you can go select the browse for the symbol file, and then you can scroll down and get the other tree source. You can add it over and hit OK. So now in the drop down, we should see that new tree. We're going to go with this other one here. If we want to change the color, we can under the style color. And then if we want to scale it to the size of the tree, we can put it to the spread. And then as we zoom in here, we'll see as our larger trees have a bigger symbol than some of our newer, smaller ones. So it makes it a little more realistic to look at. This next section is geared towards the GIS users that want to process their TerraSync SSF files within TBC. So those of you unfamiliar with TerraSync, it's the mapping data collection software, so similar to Access, but on the mapping side. So currently there's no data dictionary editor in TBC, so you are unable to create a data dictionary like you are the FXL for Access in TBC. So the way you can access or create those is through Pathfinder Office or Positions Desktop add-in. You can use existing ones as long as they match the schema of the database. So to import your TerraSync SSF, you'll obviously still need to use the data transfer to get the file off the handheld onto the computer. And then you can either use the drag and drop, or you can use the import command to browse for your files. So it'll pop up a window similar to this one, and you'll need to make sure you turn off the RTX post-processing, as it's not supported with TerraSync. We'll use a single base to correct our data off of. So the post-processing, it'll go through what's called an internet download, or that'll be the connection to your single base. So you can correct off one of those. You can have multiple in your list if you want to try correcting off multiple base stations for the best possible correction type. And then those, once you download the files, you'll import those observation files similar to how you would with the SSF file. Once you go ahead and process the file, it'll run the process and then it'll create a session for that processing. Within that session, you can go ahead and edit some of your satellites. So if you see some satellites that are getting a poor coverage, you can kick those out of the equation and then you can reprocess the file and just use the best satellites possible. So as you can see there, we'll talk about it a little later when we go through the demo. But the G stands for GPS, R is GLONASS, E is Galileo, C is BeiDou, and J is QZSS. So you can toggle any of those off and on as the process goes. But obviously your receiver has to support that satellite type for it to be able to use those to begin with. So we'll go ahead and jump in and show how to process and import those SSF files. So the first thing we're going to do here in this demo is add in the TerraSync SSF file. So I'm just going to use the drag and drop into the map screen. So I'll take that SSF, drop it in, and then once it processes, it'll pop up the import window. We'll need to make sure we uncheck that RTX PP if it tries to check that by default, and then we'll go ahead and hit OK. And it's going to add in, under the imported files, we'll see our TBC SSF file there. So the first thing that we want to do is to process the data is go to the GIS tab and click the internet download. So to add our base station, we'll go ahead and click on the internet download configuration and it'll pop up a window. We'll click new site. So if we want to use just Trimble's base station list to select a base station from, we'll do the select from predefined list. If we have information about our base station that's a custom one or a private one that's not on that list, we can choose the option to enter details manually. But we're going to just select it off the list, so we'll choose that option and hit OK. And we'll see all of the ones within our list that we can select. So I'm going to select this one down here. Then I'll hit OK, and it'll add it in there. So now we'll go ahead and select our reference station, and then you can choose your download type, either automatic or manual. We're going to go with automatic, so it just picks up the time span of our SSF file. We can overwrite this and do a user input if we wish, and do it manual as well, and select the time that you want that file for. But I'm just going to have it pick up the time from the project itself. So I'll hit that and hit OK, and it's going to go ahead and download that. Okay, and now that our observation files from the base station have been downloaded, we're going to go ahead and click the import to import them. And we'll see the similar window to the SSF file. And then we're just going to go ahead and hit OK. And we can view a summary report if we wish. I'm just going to go ahead and hit no. And then you'll see that the process baseline button is now enabled, so we can now process our SSF against the observation files from the reference station. And we can hit yes on the error if you get any. And the error was just due to the receiver not being added into TBC. So it's going to go ahead and process. And then once it's processed, we can hit save. So now if you want to do the session editor, like I was talking about earlier, where you can view the different satellites that were used and turn them on and off, you can right click on the session so we can see that that's our base station that we used from over in our list. And then we can go to the session editor. From there, we can go ahead and look at the satellite coverage, and we can see that some of those were only partially used for the file, like this G17 and G24. So if we want to turn them off, we just click on the name and they'll gray out. and then we can hit OK. And to reprocess that file, we can just hit process baseline again. And that'll correct the data without those stations in there, or satellites in there. Can hit save again. And now our data is post-processed. The last steps to the GIS module is to actually write the data from TBC to the GIS data source. Before we do that, we may want to make sure we're recording some of the metadata from TBC over into the GIS data source. So to do that, we need to make sure that our fields are set up ahead of time. So in my GIS database over on the right, you can see that I've got some DOPS and some accuracy fields there. So I have had to make sure that those field types match the field type of TBC so that they can be written over there. It is easier if you make the names match between your different features, so that way it can pick up and map them all at once instead of having to select them individually. Just be aware that right now the only metadata that can come across is from Access and not from TerraSync. So once we have those metadata fields mapped, we can go ahead and write the data to the GIS source. So from there, we'll select our profile that we've been using, and then it'll tell us when we select the data how many are new and going to be written into the GIS source and how many are already over there. We can check the box to overwrite the files or the features that are already in that GIS data source, but it may create duplicates, so be aware of that. Now we'll jump into a demo and show this last piece off. To map the metadata in TBC, we're going to go ahead and go to the GIS tab, and then we're going to click the Map Metadata button. In the Select GIS Data Connection, we'll select the connection that we've been using to our water data, and then it's going to automatically pick up the RDK vectors. If it doesn't, you can select it in the drop-down. So now we'll want to map those metadata fields together. So my first one here is PDOP. So when I click on it, anything that's double will be bolded as usable. So if we scroll down, we can see our PDOP here. So we'll click it so that they're both selected, and then we can check the box for Map All GIS Fields with the same name. So that'll pick up anything that it's down lower in other fields, like in our fittings and our hydrants that have that PDOP field. It'll go ahead and map them together. So if we add map, we can see that it picks up all the PDOP fields. So when I was talking earlier about the naming conventions, making them consistent, this is why. So it just quickly maps them without you having to go and select each one individually. So we'll continue and do our other values. And now we've got our long list of all our features that have those metadata fields. So once that's mapped, we'll go ahead and hit close. Now that the metadata has been mapped, we're ready to send the actual data over from TBC to the GIS module. So we'll do that through, on the GIS tab, the Write Features to GIS button. So once we click that, we'll see our database connection and how many features we have selected and where they're going to write to. So one thing to mention here is the access data and the TerraSync data will write through different scripts over to the GIS source. So we'll have to select those separately so that they'll write. So we'll do the TerraSync data first. So this will be all our points over on this side. So once we select them, looks like we've already sent them once to the database, so they'll show as linked, but we can write them again if we wish. It may create duplicates in some instances, but we'll go ahead and write them again, and it may pop up your coordinate system manager, and then it'll tell us that 11 were written, and if we want to view the report, I'm going to click no, and then I'm going to do the same stuff or same steps with it. Access data, and we'll see that we haven't sent this one over yet, so it's going to show under the new column. So we can go ahead and hit OK, and then it's going to write that to the database. Now we'll go ahead and switch over to ArcMap, and then we'll go ahead and open a map with our database in it. And you'll see that they're automatically there. So if we zoom in, we can see all of our water features as well as all of our trees that we've imported over. And so if we look at the table here, we can see the data that came over from Access, and it has all those values populated.